Imagine floating 250 miles above Earth, performing routine maintenance on the outside of a space station. You press a clean, unheated titanium wrench directly against a matching titanium bolt to tighten it. But when you try to pull the wrench away, it refuses to budge. You twist, pull, and use all your strength, but the tool is completely stuck. No heat was applied, no glue, no sparks flew. Yet those two separate pieces of metal have instantly and permanently fused into a single solid object. Down here on Earth, we stack metal weights, throw tools into steel toolboxes, and even crash cars together. The metal might bend or scratch, but the pieces always remain separate. We operate on the assumption that solid objects have strict, permanent borders. A wrench is a wrench, a bolt is a bolt, and they stay that way. Yet the laws of quantum mechanics dictate the exact opposite. If two pieces of identical, pure metal touch, their atomic structure commands them to merge. Why do our tools behave predictably down here, but act like a physical glitch in the vacuum of space? To see why metal naturally wants to fuse, we have to look close, down to the microscopic atomic structure of a solid block of steel. This is a metallic bond, a rigid grid of positively charged atoms submerged in a glowing sea of free-flowing electrons. Because these electrons are freely shared, edge atoms constantly reach out, looking to share electrons with nearby identical atoms. The only reason two solid steel blocks don't just merge on your workbench is the air you are breathing. Exposed to the atmosphere, oxygen and moisture crash into the bare metal surface, forming a microscopic barrier. This oxide layer acts like atomic Teflon. When two metal blocks touch on Earth, their pure atomic grids never actually meet, physically blocked by these clashing, jagged shields. The physical separation of the objects we interact with every day is an illusion, maintained entirely by the gases in our atmosphere. Looking from low Earth orbit, you can clearly see the thin blue line of our atmosphere giving way to the absolute blackness of space. Out there, those protective gases simply do not exist. If a tool slips and scratches off that microscopic oxide layer in the void, there is no surrounding oxygen available to rebuild the shield. When those pure, unprotected atoms touch another piece of bare metal, the physical border vanishes. The sea of electrons flows across the gap instantly, binding the two grids together. This process is called cold welding. Without the atmospheric barrier, atoms have no way of knowing they belong to different pieces. The objects seamlessly become one. This is a close-up of the Galileo Space Probe. Notice the complex umbrella-like folding antenna at the top, which was tightly secured by interlocking titanium ribs and structural pins. Galileo's launch was delayed for years, forcing it to be transported across the country multiple times by truck. During those long trips, microscopic vibrations from the road silently scrubbed the protective oxide layer off those titanium pins. When the probe finally reached the pure vacuum of space, those bare metal pins were still pressed tightly against their sockets. The atoms touched, shared electrons, and permanently cold welded together. Inside Mission Control, engineers faced a crisis. When they sent the command to deploy, the billion-dollar probe's primary antenna refused to open. The metal had fused shut. This failure forced the aerospace industry to rethink how they design machines destined for the void. Today, aerospace components are assembled in sterile cleanrooms. Engineers deliberately design moving parts using dissimilar metals, because mismatched atomic structures are far less likely to fuse, and coat them in specialized dry lubricants that survive in a vacuum. Modern material scientists have weaponized this atomic glitch, turning it into a manufacturing superpower. In the field of nanotechnology, researchers build electronics so small that the heat from a soldering iron would melt the entire device. Instead, they place microscopic gold nanowires inside a vacuum chamber and let them touch. They cold weld seamlessly. The boundaries between solid objects are conditional. By studying the cold, empty vacuum of space, we learned that beneath our atmosphere, the universe is built to become whole.